Okay, today we are going to do the long division of a polynomial. We're going to divide x cubed plus 10x squared plus 32x plus 32 by x plus 4. And what we're going to do is we're going to take the first term of the polynomial and divide it by x. And when we simplify it, we get x squared. Now we're going to record it above our x squared term. And then we're going to multiply the x squared by x plus 4. Expand that, we get x cubed plus 4x squared, and we are going to then write that underneath its corresponding term. So x cubed plus 4x squared, and now we got to go through, and when we want to combine these and get rid of our x cubes. So that means we're really going to change the signs of everything through it by multiplying by a -1. So we change that sign, we change that sign, combine our like terms. Our first term eliminates. Second one is 6x squared. We're going to go ahead and bring everything else down so that we don't lose anything. 32x squared, 32x plus 32. We're going to repeat the process. We're going to start out with the first term that remains, which is 6x squared. We're going to divide it by x. And when we simplify, we get 6x. We're going to take 6x, record it, and then we're going to multiply it by x plus 4 to get 6x squared plus 24x. Okay, we're going to wait for that to get caught up here. 12 plus 24x. We're going to record that, change our signs, and then simplify. So we're going to change our signs here. Alright, that means our 6x squareds go away, and that leaves us with 8x plus 32. We're going to repeat the process one more time. So 8x divided by x is going to give us a positive 8. We're going to take and multiply that after we record it by x plus 4. And what it's going to give us is 8x plus 32. And how fortuitous that ends up being the same thing, because that means when you get a remainder of 0, once you change the signs and combine all like terms, it means it is a factor of the polynomial x cubed plus 10x squared plus 32x plus 32. Now remember, our instructions said to factor completely. So now we're going to go and see if x squared plus 6x plus 8 is a factor, is factorable. So what we're going to do is we are going to take x plus 4, and that's going to be one of our factors. Now, if I can look at my first and my last term, multiply them together and get 8, well, the factors of 8 are 1 and 8. Well, when we combine those, we either get a 9 or 7, or we have 2 and 4. Well, I can either, if I got 2 and 4, if I subtract 2 from 4, I get 2, but if I add both of them together, I get 6. And so we do factor. It factors nicely, actually. So, this thing decides to be nice because I don't want to have to rewrite that. Just want it to show up here, and we are going to. Okay, we're off the page a little bit, and we lost part of our x. So we'll fix that in just 1 second here. Right. Let's go ahead and there we go. Now that factors it to x. Yes, it does factor. We figured that out already. Does this factor? Yes, it does. Alright. So we're going to get our x plus 2 and our x plus 4. Now don't get this confused with what we divided earlier. We divided the x plus the degree of 5 to get this x squared. I mean the degree of 3, x cubed. Okay, so it is a factor of that particular polynomial. We'll copy it down here so I don't have to rewrite it. Well, maybe. Technology when it works. Wants to make it too big, and I don't want it too big, so I'm going to have to rewrite it. So we're going to just write it down here real quick. So the factors of x cubed plus 10x squared plus 32x plus 32 happen to be x plus 2, x plus 2 times x plus 4 squared. X plus 2 is x plus 4, that's the one in the green, and then the one from our original, that's so that we got a double root at x plus 4. Alright, we're going to try it again. This time we're taking an x squared and we're going to divide it into a fifth degree polynomial. So we're going to take our first term that is underneath the division. We're going to divide by x squared, simplify it, gives us x cubed, and we're going to multiply it by x squared minus 3. It's going to give us x to the 5th power, subtract 3x cubed. Write that down, change our signs. So minus 3x cubed. Our bar there, and change those. First two terms actually now add out. So now we're just going to carry down what's left over. X squared subtract 24. We're now going to take x squared, we're going to divide it by x squared, and we get 8. So 8 times x squared minus 3 is going to give us 8x squared subtract 24. And then we are going to record those and then change our signs. Remainder is 0. Now we're going to see if we can factor the x cubed plus 8 further. Yes, we can, because that is the sum of two perfect cubes. The cube root of x cubed is x, and the cube root of 8 is 2. If you remember that the cube root pattern is that the first root plus the second root, so it's going to have the same sign, and then, oops, that should be a negative in between. So the second one would be x squared subtract 2x plus 4. So when you do this, remember that middle term, the x squared plus 2x plus 4, is actually a subtraction. And we would multiply that by x squared minus 3. Instead of fighting with the picture redraw tool, I'm just going to write it down that we're going to have x plus 2, and that should again be an x squared minus 2x plus 4, and we're going to multiply it by our original divisor. Okay, on down to the next one. So now we got 4x raised to the 4th power, subtract 2x cubed, subtract 3x minus 9. We're going to divide that by 2, not too much though, so we're going to take it in pieces. 2 goes into 4 exactly 2 times, and then x goes into the x4 3 times. So now we're going to take 2x cubed, we're going to multiply it by 2x minus 3, and that gives us 4x to the 4th power. Okay, and we're going to get a negative 6x cubed. Okay, so now here we go. 4x to the 4th minus 6x cubed. And write those down. Change our signs. And we're going to get 4x cubed. Subtract 3x. Subtract 9. Alright, now we're going to take 4x cubed. We're going to divide it by 2x. And that's going to give us again 2, and now we're going to have x squared. 2x squared, we're going to multiply that by 2x minus 3. Alright, it's going to give us 4x cubed. Okay, there's 4x cubed, and okay, we'll multiply those two together. Okay, we're going to change our signs. Alright, I didn't leave any space for my 3x squared. Because our powers went from 4, 3, 1. So I'm just going to move this over because we cannot combine a 3x with a 3x squared. So I'm just going to hold those and grab it and slide it on over a little bit. Okay, now if you come across one of those positions, one of those things, you can just come over and just tell it, you know, let's put in just a holder of 0x squared. That is something that is a good practice. You just go through your powers, and if there's a place, you could actually put a holding place in there. Alright, so now we've got 3x squared, subtract 3x, minus 9. And, wait a minute. If I'm multiplying by 2, I should have an even number. Yeah. Okay, so 2 times negative 3 is not negative 3, it's a negative 6. Okay, so let's go in here and fix that. Negative 6 over here. Come on down. Now we're going to put down negative 6x squared. See, I shouldn't do this after teaching all day. Very tired. 2x equals negative 3x. Now we're going to take and multiply that by our factor of 2x minus 3. We're going to get negative 6x squared. And a negative 3 times a negative 3 gives me a positive 27, and then we have x as a factor. So we're just going to write this down. Negative 6x squared plus 27x. We're going to change our signs. So that's going to be a plus 6x squared, and that's going to give us a total of a negative 30x minus 9. We're going to do this another time. 30 divided by x, negative 30x divided by 2x is going to give us a negative 15. And we're going to multiply that by negative 2x minus 3. Going to give us negative 30x, and we're going to get positive 45. So let's write those down. Just a minute. 30x plus 45. And even when I change my signs, I can see that I'm going to have a remainder, which means that this is not a factor of our polynomial. Okay? Not a factor at all. Okay, so that's what we have.